Okay, so it's week 5 here. Uh, hope you survived me being gone last week. Um, Week 5 we kind of transitioned to a new kind of portion of this course. The first 4 weeks is kind of a mix of theory and computational theory and programming language theory, where we're looking at grammars and stuff like that. Um, and then for the next 4 or 5 weeks, we'll actually do more practical stuff in programming languages here, where we'll do kind of look at each different aspects of programming languages and look at them in more detail. So today we start talking about the type system, variables, variable types, and how that works, how our variable is bound, when are they bound, and that sort of stuff. And next week, we'll look at more advanced pointers and reference types and collections, generics, some more advanced features there. And then unit 7, we talk about control flow. So that's your loops, your if-then statements, your switch statements, stuff like that. We'll then look at composite types and collections after that here, where we'll talk about, like arrays and lists and classes, stuff like that. And not classes, just arrays, lists, collections, iterators, those sorts of kind of ideas. And then unit 9, we'll do classes, subroutines, functions, methods, whatever you want to call those things here. So those are the main parts. Next, unit 10 will jump into what's called functional programming and lambda methods. Functional programming is a whole different kind of way of programming, and we'll talk about how there are some very classic or exact functional programming languages, but we also are seeing functional programming languages kind of coming into, or at least the ideas or concepts of them, into some of our other languages. So in like a Flutter or a React sort of environment for this. So again, a lot of this is more applied than we have been looking at so far for the next 4 weeks. So you might like that. You might not. It'll just be different. So I'm trying to get caught up on grading here. I want to apologize for assignment 2 here. Assignment 2 wasn't very clear. I thought it was very clear when I created it, but it wasn't. So I know a number of you. So I tried to be lenient in grading assignment 2 here, and then I kind of tweaked it for the next time we offer it here, and set things up. One of the so a couple of things that were wrong with it. One thing I didn't like is that I had an image of for the book, and I couldn't copy and paste from that image. So I replaced that with actual text from instead of the image from the textbook or a textbook. The other thing is, like in question 1, I had this, I don't know if I had an if or a while loop. I had some loop here, but it wasn't actually in this Ren language. It wasn't in the right syntax there. And I just want to show you, this is how I kind of hoped you would do things and where things went wrong. So the idea is that if you start with a command, can you end up with this statement here? And the idea is that you would apply these rules here. So like a command can be one of these things here. So you can take a command and replace it with this while loop here. So command is this while loop. So now your command becomes this result here. And that maybe has a command sequence in it. So you can replace command sequence with a command, semicolon, a command So now you've got this here. And then there's still a command sequence in there, and then you can do, well, actually, yeah, this one. You can replace this command sequence with just the command. So now you've got while, a Boolean term, do, command, semicolon, command, and while here. So that's your, and then again, you can keep following these by replacing like a Boolean term with Boolean element here. And then a Boolean element with a comparison for this. So you start with the Boolean expression, you convert it to a Boolean term, you convert that to a comparison, you convert the comparison into an integer expression, a relationship in an integer expression. You can then replace the relation with the actual like less than or equal to here. So every time you can apply one of these rules, there are a lot. I didn't realize how many exact rules you have to do to get this simple statement to work on. So that was my mistake. And again, so a number of you realized that and started to apply multiple terms like this. So we're going to, for this term, we're going to replace that with an element. The element's going to be a variable. The variable is going to be an identifier. The identifier is going to be a letter, and the letter is going to be I. So basically, this term is going to turn into an I. So where this term is, we now have an I here, or a 1 here. So, so that's what we're kind of looking at here. So I tried to be lenient and update. I just want to say I'm creating. I mean, since it's a new course, all these assignments are brand new. So I tried to do my best on these assignments, but sometimes I don't. I mean, they're a little bit unclear. So bear with me as we refine these. And again, if you see something that's wrong, make sure you point out to me or help me correct these. So. Okay, let's get back into Unit 5 then. So I'm going to go into the learning resources. We'll just talk a little bit about, explore what's in some of these textbooks and stuff, and then we'll eventually get into some prompts for you to look at here. So again, this course kind of looks at two different things, a theory of a computational theory course and a programming languages course. We are going more into the programming language aspect of it now in the next 4 weeks here. So here's Sebesta's programming language text, which is a well-known text in this area. And again, Sebesta has a number, well, we'll cover this. So we talked about some programming language and stuff, syntax and semantics, and lexical kind of analysis. And now we're getting into this chapter 5, names and bindings and scope, and also chapter 6 on data types here. So let me jump down to one. So again, we're talking about names of identifiers and variables and how we define a variable and how we set the type of the variable. And Sylvester goes into a lot of detail about what languages in the 1970s and 80s and how they set up. One of the things you'll find, one of the reasons I don't like these textbooks so much is that they tend to have been written about 20 years ago and then been updated with multiple editions. But a lot, like half of the textbook at least is still from 20 years ago with these old languages and stuff like that here. So it's talking about that sort of idea here. Um, what camel course is and special. So again, we have names, we have reserved words that we can't have variables named after, and different languages will have different variable names. We'll talk about variables and names and addresses here. We'll talk about its type here. So a variable has to have a type, is how the memory, how we interpret the memory and how much memory we assigned to that variable name for this. And then it has a value, what is actually stored in that memory location for this. We get this concept of binding, and binding is like when we tie a variable's name to its type, when we actually like set aside the memory there and how much memory do we need, and kind of associate that memory location with this variable name for this. And we'll talk about different types when we do bindings and how we might do type bindings. There's two main types: static type binding, where we explicitly say that this is an integer variable, or this is a long variable, this is a float variable, this is a character variable, where we explicitly say the type of a variable. And so then when we compile it, we can bind that, we can set aside that memory for that variable, and we know what type it is because it's very explicit, and it's easy to set this up here. The other kind of thing is dynamic typing, where again we don't we just say variable, x is 4. When we run the program, the compiler actually looks at that and says, oh, we need a variable x, and it looks like this is an integer, so we're going to say set aside an integer variable for it here. So dynamic stuff is again where we're doing it more at runtime and interpreting as we're going through the language, each line statement by statement, kind of interpreting it, or and what variables are needed, and we can change a variable type later on if we set that variable to the word Duluth. It would all of a sudden change to a string type for it. So we'll talk more about this dynamic and static typing in some of the prompts today, and look at some languages that do that here. We'll also talk about how variables are stored. Particularly, we'll look at static variables here and stack dynamic variables. Variables that are stored in the stack and variables that are static are two main types. We'll also talk a little bit about heap, and most programming languages don't allow you to do heap kind of storage. This is a low-level thing that's done in C and C++. But we'll talk about it and a little bit about what it is here. So do you have a pretty good idea of how variables, when we declare them, what a stack is and what static is? Think about that. And in a sec, we'll look at an example and we'll talk about if you have a good visualization of that here. Once we start talking about that, how it's stored, we'll also brings up scope. And I think you're pretty familiar with scope. So where is a variable allowed or useful or defined in? What part of that? Is it a global variable? Is it local to a class? Is it local to a method or a function? Is it local to a block here? We'll talk a little bit about how we set the scope of a variable here. And when we reference a variable like x here, does it mean this x or that x? Which x does it mean for this? Last thing that's sometimes mentioned here is declaration order. In most languages, this isn't important anymore, is that the order you declare the variables in and where you declare your variables. Were you taught when you write Java programs like a Java method or a Java class, where do you put the variable declarations? You put it at the top of the class, you put them at the bottom of the class, or you spread them wherever you need them, you put in the declarations. How were you taught? Or how to use the program things.
Usually Gary was on Google, so I just put up the top.
It's top of the class.
Yeah.
So. Oh, and I was taught to always put them at the top, although I sometimes see nowadays people put them at the bottom of the class, which seems strange to me there. But again, the order that you declare them in doesn't really matter in most modern programming languages today. Okay. I'm going to scroll down to this next chapter, which is on types here. Okay, so we're going to look at types, particularly primitive types, integers, floating point numbers, that sort of stuff. Some languages have things like complex or irrational numbers, decimal numbers. Certainly, almost every language will have a Boolean type and a character type. How we handle strings varies a little bit. And some languages will have a built-in string type. Other ones will treat like string as an array of characters or a collection of characters. So their primitive type is just a collection for this. And then we'll look at some rules on how big these different values are. How big can an integer be? How much detail can we have in a float? How long can a string be? Can a string be 1,000 characters? Is 10,000 characters? Is there a limit for this string size? And then we'll look at some specialized types, enumerated types here, and talk a little bit about those. And then next week, we're going to get into arrays and and pointers and stuff like that. So we'll talk more about arrays and pointers or addresses and pass by reference sort of stuff next week. That's one textbook. Let's look at one more here real quick. I want to bring up Scott's one. So again, Scott jumps into names, scopes, and bindings right away in Unit 3 here and talks about it. I don't know if I'm going to jump into text. I'm just going to talk a little. I'll just walk through this overview, I think, here. Talks about memory location, static, stack-based, or heap-based, and that gets into this idea of garbage collection. So we'll have to talk about what that is. Talks about scope rules, where things are scoped. Are they statically scoped? Are they in subroutines? Is the declaration order matter? That sort of stuff here. Talk about binding and binding within a scope and how that works here. So not too much here on the primitive types and the type systems here, more on the scope and stuff like that. Okay, so let's jump into an example. I think one of the most important things to get here is to understand what the stack is when you declare variables or classes. How does the stack work? And what and how that works. So we're going to look at this car. Oh, that's really weird. I should set that up so you didn't need to log in. So. I'm gonna look at this example in Java of a class, and how with it has both a static variable and non-static variables, and work with that. Now, we're going to want to be looking at lots of examples here of code. And so I've been trying to figure out what sort of environment we should be coding things or running code in, because I want to be able to run Java code, Python code, JavaScript code. Be nice to be able to run C code at times, and maybe some other languages. So I looked around. The best I could find is Tutorial Point's website here. They have a bunch of online compilers in lots of different languages here. And you can just access those. So for now, that's my best bet. So we're gonna try that this week and stuff. If you know of a better environment for programming in, let me know there. I don't know if you are like when you are doing interviews or companies are working with you and you're having programming on whiteboard stuff or things like that, if you have a different place. But I'm going to use this Tutorial Point stuff. And so here's their compilers in the main languages I think we'll be jumping into or looking at. And I'm just going to start with their Java environment. And I'm just going to take this public car class and paste this in here for now. So I'm going to replace this class with this new class here. So so again, this is a class called car. Each car has a color here. We have a constructor where we say, give me a green car or give me a black car. So we give it a car color here. We have a method to display the car information. It says the color here. We also have a variable, a static variable for the total number of cars here. So this is static. So every time we create a car, we add to the total number of cars here. So when we display a car, we also say the total number of cars here. And here's our main routine where we're creating these cars for this. And then we're printing. So if I just execute this code here, I don't know why I'm not able to execute this code. Yeah, well, try this again. There, okay. So it creates a red car. So down here we say, we do a new car and make a red car. And we create that. So it prints out, the constructor runs there. And then we're going to display the red car and the red car information here. So we will instantiate a red car, a blue car, and a green car, and then we'll print out the information about each car as we go here. So in all cases, there are 3 cars created. So by the time we print this out, there are 3 cars created for this because of this static variable. So the question I have is that when you look at code like this, do you create some sort of visualization? I'm going to do it on a board here, I think. So I imagine memory So this is all of our memory that our program's going to run in. And we have our code up at the top. So this is our Java code. And inside that Java code are our static variables. So things like the total number of cars. We have some storage up there for that. So this is our Java code in memory. And then down at the bottom here, we have our stack down here. And then so when we instantiate something, like we go here, we'll do red car equals a new red car. So we'll instantiate a new red car or new car. And every car has some local variables. One, in this case, just one, a color. And we're making a red car in here. And then we're gonna instantiate a new car. So we're gonna create another car, and its color is gonna be something else. And then we're gonna instantiate another car. So we created, what did we do? We do a red car. Next, we instantiate a new blue car. The next one's blue. And the next one is green. So again, there's two sections of memory. One holds the code. So this is all of memory. And this is the stack. And this is the code or the static area up here. So inside the static area where the code is, with execute there, the static variable are stored up there, and there's just one version of those, right, for the whole class. But then whenever we instantiate one, a car here, we instantiate a car here, we'll create a memory, allocate memory for it, and any of the local variables for that car. So each car has its own color variable put on the stack for this. And the stack, what we'll do is, like, when we call a method, we will, and we pass parameters that method, we'll push those parameters onto the stack. And if it has local variables, we'll push those local variables onto the stack. We'll keep pushing things onto the stack and accessing them. So you've all had, or a lot of you've had, data structures. And what's your rules of accessing a stack? What makes a stack a stack? Only add to the top and only take things off to the top. So we call this a stack, not really a stack, right? Because we stack things on here, but we can access the red car's information, even though we've added the blue car and the green car to it. So we call it a stack from a kind of memory point of view, but it's not, from a data structure point of view, it's not really a stack here, because we can grab any of these things in here. So just be, I'd bother with some people that we call it a stack, and it's not. It breaks the rules of a stack in some ways here. So okay, so I'm going to let you get into this stuff with these prompts, I think, pretty soon. I'll just mention that again, we've got these code samples. If you want to try them out here, you can, and I've got some simple code in some different languages here. So like if you want to try out TypeScript, you should be able to open that up. You should be able to grab this code that's in TypeScript and put it in here. On some of these, we can just replace the whole thing with this code. Some of the languages like C, you need to have a main routine, I think, or something like that, and you might have to have a return in it. So you might have to look at all this. Same with Java here. We'll need to have some of that stuff here. So like here, we can just run this code. I don't know why it's not executing. Seems like it's really slow today. For this. So again, we'll be playing with these different languages here. Okay, let's jump into prompts and let you start working on that. So why don't you go down to the Unit 5 QQSPs here, jump into the Unit 5 prompts. Here, and again, make your own copy of this. Start working on it. And again, one thing I do, you might want to do is that AI will start giving you example codes in these different languages. And so far, we haven't been running any of this code. But now that we're getting a little more practical, it might be worthwhile to have these different compilers available. So if they, to check out, because sometimes AI will give you code that might not always work perfectly. So you might want to actually try. They give you some JavaScript, go to the JavaScript one and paste it and see if it actually runs that. Okay, so I'm going to be quiet, let you work through this stuff, and I'll break in a little bit to suggest a couple things. Okay, let's just see how we're doing here. So we start talking about names and identifiers and variables, some stuff. And again, from right here, you're supposed to come up with your own prompts. I have them at the bottom here, but feel free just as you're working on these to, do your own prompts as you're working on things. I was just looking at variable names that got me thinking of two things. One is, what are some common variable, because they talk about camel case here, what are some other common naming conventions here? So how many of these have you heard of or used? So one is the M for member variables, M underscore value. So any time in a class you declare a variable, it has to start with an M underscore. Have you ever heard of that? I've certainly heard and programmed in that world before. Underlines. When are there any places where you use an underline to name something, or a double underline? And is that used? So like again, in Python, this double underline sort of idea. Have you heard that? So how about Hungarian notation? I use this a lot where, again, I'll do like string name or I counter. I often do this more with user interfaces where I'll say like button, BTN, and then something, or text for text value, TXT, something like that. So when I'm doing UI interface, I use this sort of Hungarian notation. I've used that before here. How about just I for interfaces? When you're naming interface, they always start with an I. All caps for constants. Have you used that or seen that before? Booleans always start with like a verb, like is active or has permission or something like that. Booleans should start with has, can, should, or something like that here. P for pointers, you probably haven't programmed with pointers. But again, when I did C or C++ pointers, we almost always did this P and then the name of the variables. G for global variables, I've never done that, or K for constants, I've never done that either. So the other thing that got to mind is how long can be our variables names? Because I've gotten into problems where in languages before, only like the first 256 characters were read in a programming language. So if you got long variable names, they they'd get confused. But it's interesting today, all modern. I was just looking at Java and stuff. Java, the first 65,000 characters are all unique with it, so you don't have to worry about running out of variable names. I'm so old. I started programming where we couldn't have variables that were more than one character. That in the first languages I programmed in, all variables were a single character. And so you actually were limited to 26 variables because we only had 26 characters in the alphabet at that point. I remember when we started to do more than one character, that was just so exciting. Okay. So you looked at that, stacks and heap stuff. One thing you're probably, again, not that used to is heap-based storage. I'll just mention that a little bit and search for this. Yeah. In languages, in C and C++, you can just set aside, you can reserve a whole chunk of memory to use however you want here. And there's a memory allocation command, malloc, that you can use, and then you can free it up when you're done with it here. And you can use that to just set aside memory and do whatever you want. So like if you want to manage that memory however you want or whatever, or set up a 2 or 3 dimensional array in it or something like that, some weird thing, you can malloc it. And that comes off of something called the heap for storage. And again, when you're done with it, you have to then tell the computer you're done with it. Otherwise, the computer will keep it reserved for it, and even if after your program quits. And that's what's called a memory leak here. So that's, again, when you're reading through this, just be aware that when we're talking about the heap, low-level programming languages like C and C++ let you allocate memory directly and then use how you want it. So that's probably something you haven't seen necessarily before. Other than that, I think most of this stuff goes. The primitive types, again, we'll be doing on Thursday, we'll do a worksheet. We'll do some stuff with primitive types, enumeration types here, and talk about that. So I'll let you keep going here, and we'll break in, talk about typing in just a little bit. Okay, I'm gonna break in here one more time and talk about static and dynamic typing. So hopefully you've kind of looked at these prompts and you have some idea of this static typing and dynamic typing. So like Java has static typing where when you compile the program, you know what type every variable is. And every time you declare a variable, you explicitly have to say what type it is here. Where like Python and JavaScript both have dynamic typing, where we really don't know until we run the program and we look at the code, what values things are here for this. And then with JavaScript, we've got a new version of that called TypeScript, which tries to force more of this static typing here. And again, this is a place where when we're trying these out, like here, this code show an example of a JavaScript function that could lead to a runtime error and a TypeScript example of it. So if I type, what am I using? I'm using DeepSeek today. So here I put that in here, and the example it gave, right, is, and this is almost the example it always gives, is the add two numbers together. So I have a function called add numbers and give it two numbers A and B, and I add those together for that with a plus. And again, we don't say what type those variables A and B are, so we can call add numbers with 5 and 10. And we can also call it with 5 and the string 10 here. And it says this should give us a runtime error. It doesn't really give you a runtime error. It just is a different interpretation of it, meaning that it will use string concatenation. If it sees one of these parameters as a string, it'll do string concatenation here for this. So when you run this. Now, this is an area where I think it is kind of helpful to be able to run some of this code. Now we're getting more into these examples. So again, you can go in here, grab your JavaScript interpreter here. I can just paste the code in here and run it. And again, 5 plus 10 results in 15. 5 plus string 10 results in 5, 10. It'll do string concatenation of that. Now, I don't know, I would necessarily call that a runtime error because it doesn't actually give an error. I mean, it's just a different way of interpreting the results there. So I don't know if I think that's a little stretch to say that's a runtime error. I guess it depends on what you're expecting it to produce for this. And then it talks about, again, TypeScript here. So with TypeScript, when you declare a variable, you say the variable and then the type here. So A is a number, B is a number, and then the result of this is a number for this. Now, they have this TypeScript compiler here, but I'm not getting it to work today. I haven't tried it. I've tried most of these, but I've not tried the TypeScript one. When I paste this in and I type execute, it just displays the code over here. So I don't know if any of you have got the TypeScript compiler here to work. Maybe I'm doing something wrong, but let me know. Right now, when I do the TypeScript, it just prints out the code over here. I'll look some more into that, and I'll try to get, if this isn't going to work, we'll maybe try to get a different JavaScript and TypeScript interpreter or IDE that we can use. Questions on this? So remember, for your for Thursday, we want you to, oh, I should change the date on this. What I've got to do on when? October 6th. Yeah, let's do this. So let's see. We'll have the initial one due for class on Thursday, and then, so I'll just put that to remind you. And then on Thursday, we'll actually change the due date to be next Sunday for this. You're just remember to post your QQ TP, your initial posting for this by Thursday at 10 here. And then Thursday, we'll do a little discussion there. I almost have the activity for Thursday worked out. It still needs a little tweak. There's still a couple places where the questions are not where I want them to be. So I'm still working on that. I'll have that. I'll update that tomorrow. The assignment this week is here, and we'll be doing this, I think, for the next couple of weeks. Here, letting you kind of do a deep dive in different languages. So, again, pick any language. I was going to say pick your favorite language, but you don't have to necessarily pick your favorite language. Just pick a language that you're interested in and research it, learn about the primitive types, composite types, and that sort of stuff. And again, you can certainly use AI to do some of this research. Try to go. I don't want you just to do one prompt and do the AI response to that. I'd rather you use AI smartly. Ask about primitive type, ask for more stuff, and then, create a, composites, response to that sort of stuff, here. So again, pick one language, and again, you can, look at your own, here, for tutors points, they have a bunch of languages. I'll just warn you, some of these I don't really consider languages here, like CSS3, HTML. There's no real variables in that and stuff like that. So try to pick an actual programming language here, and not just because tutorial point has it doesn't mean it's a real language as far as I am concerned here. But they do have a lot of some fun languages and stuff like that. So feel free to look at those. So again, that's your assignment, is to do that this week. That'll kind of lead us to the final project in the course, where you will want to pick some topic that we covered in the course and do a little research paper on it. And it can be related to a single language or comparing a couple languages or something like that, or practical, or it can be more theoretical at that point. So, questions on that? Okay, I'll wrap up here. If you want to stick around, work still more on that, you can. I'll keep the chat thing open. And we'll see you everyone on Thursday.